Okay, you guys, let's start our today's class. I think we'd better talk about the homework last time because only two of you guys sent your homework back to me. So maybe a little bit difficult for you guys, but it's okay. Life as
Lucky, I send in your personal website.
okay. Maybe I am I did not notice that. So I think we should discuss these two homework together. Then we'll move on to the new content of chapter 3. So in order to save our time, I just show my answers here. I think the PDF version, you guys can see that. Okay? So maybe I will do some brief introduction to you guys. So let's see the first problem. So it let us determine the resultant force of the four forces at point O, right? It given the magnitude of each force is respectively uh, F1, F second, F3, and F4, right? We know its orientation already. So when we do our projection, the only important thing you guys should pay attention to is the 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 direction. You know. So let's see that when we do uh, because we know our maybe I will change the color of the pen into another color. Maybe I think maybe this. So we know our final result will be like this, right? FR equal FRX I means X direction, right? Plus FRY G direction, right? So the only thing we should do is find the result of FRX and FRY. We should use the projection method two times. Uh, one is for FRX, the second is for FRY. So when we do the projection, we all should pay attention to the correct direction. Let's see. So just use the sequence from F1 to F4. So actually our FRX equal sigma I equal 1 to 4, right? FIX. So we can see from this figure, because actually F1 is located at the fourth corner of this coordinate system, and we have it intersect angle with positive direction of x with 15 degree. So when we do this projection, we try to find the so-called f1x, right? f1x. So you guys can think about that. We just use this. We should try to push this point along this vertical line, which is perpendicular to x direction. Actually, this will be from O to here. This will be what we want to find f1x. So its magnitude will be f1 times cosine 15, right? So you can see actually this f1x, its direction is along the positive direction of x-axis, right? So here the sign will be positive, so we do not need to write it here because it is positive. Use the same rule or same manner will we consider the f second. You see, f second located here with it intersect angle 60 degree. So we project it onto x-axis again. We find magnitude of f second x will be f second times cosine 60, right? And this part also along the positive direction of x. So when we do the projection, we should always pay attention to its correct direction because it will influence our result. If you cannot give the correct uh, direction, then your result will be not correct accordingly, right? So let's see F third. F third is located here only give us it intersects angle at here with positive y direction. So we will find when we use F third times cosine 20, it will be F3 y, right? And if we do this projection onto the left part of x-axis, we should use f f third times sine 20, right? Actually, this part, this part. So its magnitude will be this one. So at this rectangle, so this length will denote the magnitude of f3 or f third x. And this time, its direction actually is along the negative direction of x. So we must give a minus sign here. So this is very important, right? So if you guys can give this expression correctly, the other thing is just to do your calculation. You can use maybe software, maybe calculator. It's okay, but this expression is very important. So the last one we can find actually is located here and it have a 30-degree intersection angle. So when we project it onto x-axis, we can find its magnitude should be f4 times cosine 30. But its direction also along the negative direction of x. So we should give a minus sign here, right? So, can you guys understand me?
Yes, Raj.
Okay. Actually, this step is very important. If if all of you guys can give this expression, so the second or the final results will be confirmed. It's not a problem, right? Because its calculation is very easy. You just need a calculator or software to calculate cosine 15, cosine 60, and sine 20, right? So the final result will be this. So please, you guys, you should pay attention to. We should give its unit. Unit in Chinese we call that 单位, right? 单位. So we always use Newton or kilonewtons to denote the unit of force. So please give this Newton to denote its unit, right? So if you can find FRX correctly, then you can find FRY also because it used the same manner. So let us do this together. So we try to use this expression to find FRY, right? So do full projection method again. Just this time, we project each force onto y-axis, right? So we use the same sequence. So we have F1 here. So we do this projection onto down part, right? So we will find actually its magnitude will just be F1 times sine 15, actually this length, right? And its direction actually along the negative direction of y. So we should give a minus sign here. This is very important because f1 times sine 15, I think all you guys will understand. So maybe someone will cannot give the correct sign here. The second, because we have f second here, so when we project it onto a y-axis, so its magnitude will be f second times what? Times, because you can use this as aided line. So this length actually is this length. So we just use f second sine times sine 60, and its direction is along positive direction of y. So it is a positive sign here, positive sign here. And absurd times cosine 20 and have a positive sign, right? And the final one, f4 times sine 30. This time, you can find actually is this. So f4 times sine 30 is its magnitude, and its direction actually also along the negative direction of y. So we give a minus sign again. You see, this one minus sign, this one positive sign. Then you just do the calculation carefully. Then you can find a final result. So actually, I can write here. After our calculation, we find maybe this is the 93.7. I just use one digit up here, I, right? And plus this one should be 137 point maybe 0 G. So then it's very, very easy for us to find this FR, actually the normal alpha vector, right? Alpha vector. We just use this one and this one. So we have to use this squared calculation 93.7 squared plus 137.0 squared. Then we can find the final result is this. And if we try to find its orientation of this FR, we can use this cosine theta equals FRX over FR. Then we have this, and we can find this, right? So if you also want to find cosine beta, which means it's cosine result of FR between FR and the y-axis. So we can use this. Just use 107.0 over, right? So the other things you can do it by yourself. So actually, I think this kind of problem, I hope all you guys can do it by yourself. Okay? I think this not that difficult. I hope all you guys can grasp the method, can find the final result correctly. Okay? So if some guys do not send your homework to me, I highly recommend that you finish by yourself again, right? Try to understand how to do this and do all the calculation by yourself again, right? Please. So we will continue to talk about the second one. So let's see the problem. So it tells us the framework is composed of block M. Actually it may be a box or something, right? Have a gravitational force G here. Bar AB and bar BC hinged at point A and point C. Actually, it tells us at point A and point C, there are two seam constraints. We call that fixed. Fixed hinge or fixed pin. Do you guys remember? I hope you guys should know 5 common type of constraints because different type of constraint, it will have different reaction force, right? So actually tell us this is very simple two hinged, fixed hinged, right? And it tells the weight of the block is G, we know, and the weights of the bars are neglected. So whenever you guys encounter this condition, it almost try to tell us you guys should consider first, does AB and BC, maybe this guy will be double force load. Do you guys remember? So if we have a rod, it only have force acted at 2 points, maybe like AB at A and B, and it in the state of balanced, and its weight is neglected, then we should think about actually AB and BC will be double force balanced rod. Do you guys still remember? In Chinese we call that 二力杆. So if a rod is a double force balanced rod, then its force analysis is very easy. No? So that is maybe I can draw here actually let this AB. So because from the condition we know that AB actually is 二力杆 double force balanced rod, then it maybe have two force FA and FB. This pair of force will have these characteristics. One, FA and FB have same magnitude and opposite direction and collinear along the link line of linking A and B. So we will think if we can find the magnitude FB, then we will know FA2, right? So for the same reason, maybe I can draw here. I'm sorry, it's very ugly, but I hope you guys can understand me. So this BC, so it will, this is FBC, and this is FBC. So I write subscript with B and C just to different with this FB. So maybe these two forces will be away from each other. Maybe it will be point to each other. So actually in China we call this one is 两端受拉, right? And this one is 两端受压. So once again, because all the system is in equilibrium condition or in the state of balanced, so we can select the node B as an object to be studied. So we can just think this time we just select B, not B. Not means 节点, you know, not. So, and we should consider what? Consider, so here it have active force G, right? Because it is known condition. It is because the gravitational force of this box M, right? And we also should from the point of action and reaction force point of view. So if this BC is the 二力杆 is pushed at point B, actually we can think about that actually this force is pushed by node B onto BC at point B. So if this node push BC, and then BC will have a reaction force along the same direction. Can you guys Understand? Actually, it will have this. We can write maybe FBC prime. Actually, it means this FBC prime actually and this FBC is a pair of action and reaction force, right? So if we from the original figure just elongation this CB, we will find if this 60 this rectangle, this will be 30, right? And this is another rectangle, so this angle should be 60. So we have this, right? So once again, because of the same reason or using the same manner, so when we select this not B as an object to be studied, so if AB is pulled at point B by some object, it should be this knot. So if AB have this force FB here, it will also have a reaction force. You see? We can write as FB prime. So this angle will be what? This angle will be 30. So I think the process of analysis is very important. When we give this analysis result, right? So we can see actually it is a concurrent force system. Only have 3 forces, and actually this active force G, its direction and magnitude is known. It does not tell us what the real value of G is, but we can think actually this G is known. We can just use this letter G to denote its magnitude. So our text now is just to find the magnitude of FB prime and FBC prime using the equilibrium condition of a concurrent force system. See? Is that right? Can you guys understand me? So now yes, now
Yes,
I
sir.
can, what? So now I can show you guys the final results. So you see, actually this one is almost the same, this one, right? So it is a concurrent force system in the state of balanced. So we just need to use the equilibrium condition twice. So the first condition is sigma fx equals 0. So we should project all these 3 forces onto x-axis. So our default coordinate system always x point to right along the horizontal line, and y-axis in positive direction will be upward, right? So we can do that together. You see, we have FB prime times cosine 30. Its direction is along negative direction of x-axis. So it will have what? It will have a negative sign here, minus sign here, and FBC prime. Does anyone have problem? PE number 4, maybe I will shut off your noisy number 4. Sorry. Okay. So let's continue. So what happened? So FBC prime here, when we so its projection onto x-axis in magnitude will be FBC prime times cosine 60 because it's along the positive direction, so it have a positive sign here. Then we will use this condition. Sigma Fy equals 0. Actually, because this direction G is perpendicular to x-axis, so its projection will be 0. So we do not need to consider this force when we do this. equation, right? So this time we can use fb prime times sine 30. Its direction along the positive direction of y. So we have a positive sign here. Because it is the first part of this equation, so you maybe you can you do not need to write the positive sign here. And the second item, we have FBC prime times sine 60, also along the positive direction of y-axis. And the third one is G, you can find actually its whole length along the negative direction of y. So we have minus G equals 0. Then our task is to try to solve this very easy equation. So maybe it is a linear equation, right? 线性方程组 linear equations 线性方程组。So because cosine 30 is a half, right? And the cosine 60 squared 3 over 2, and this one. So I think the consequence step is not difficult for you guys. So you just need pay attention to and do this very carefully. Then you can find its final result. So actually we will find FBC prime actually equal squared third over 2 times G, and FB prime equal half G. So back to the answer. Determine the internal force of bar AB and bar BC respectively. It let us find the internal force of bar AB. So how should we understand the so-called internal force? So let me tell you. So it means I just select AB to do the introduction to you guys. So because we have the conclusion that AB is a double force balanced rod. So we have this FA and this FB. So what is internal force? Actually, this concept will be used next semester. So we also have engineering mechanics. Second is another course. Maybe the teacher also be me, right? I'm glad if the teacher will be me again. I'm very glad that. So that time we'll talk to internal force all the time. So what that mean? So you can see actually this AB, it is a rod, double force balanced rod, right? And FA and FB is direction and magnitude we have get. Actually, we know actually it half G. This is half G, right? But what is internal force? Actually, if we think this AB as a whole part is in the state of balanced. If we try to find its internal force, we can imaginary think about that we cut it into two parts. Just select position and we do this. It's not what I want. That means we just actually this is the left part. So we think we use this plane, maybe plane 1, 1, cut this AB into two parts, and we just select the left part to be started. because the whole part of AB will be in the state of balanced. Then the one of its part also should be in the state of balanced. But we think or imaginary think that we discard the right part, but we should use a force to denote its action to the left part. So that is the so-called internal force. Maybe we use FNAB. You see? Actually, this FNAB actually is the internal force because we will have this internal force to keep this part of AB also in the state of balanced. So maybe we give a coordinate system with x. So when we use sigma x equals 0, so we will have this equation very easy, FA minus FNAB equals 0. So we can find actually FNAB equal FA. That's why we only select not B as an object to be studied. So because we can find the internal force indirectly, because we know I just introduced this principle to you guys. So the other time we do not do this again. We only need to select this not as an object to be studied. We find the magnitude of FAO or FB or FB prime. Actually, our other things is done. It's done, right? We can just give the result. Actually, the internal force of bar AB actually equal what? FB prime. And bar BC is FBC prime, right? That's the whole reason why we do that using this precise. I hope my introduction to you guys will help you guys have some deep understanding of this problem here, right? And I hope all you guys can finish these two homework. So when you done that, you can send your result to me, right? So I think that's all for these two homework. We'll continue to move the new chapters, right? Okay. We will continue to talk about chapter 3. I think we have a short start last time. So actually this chapter have 4 sections. We'll continue to do that. So the first section will talk about how to changing the line of action of force. Actually, we have very important principle of the theorem. So a force acting on the rigid body can be moved parallel to its lines of action to any point of the body. So the first thing we should think about, why should we move a force from its original action point to another point? Because we will try to do some reduction of a force system. So before we do that, we should learn this theorem. So force acting on a rigid body like we have F is magnitude and direction, also known at point A, and can be moved parallel. What is parallel? When this move is happening, the magnitude and the direction of the force will keep to its original value, right? Move to parallel to its line of action to any point of the body. If we add a couple with a moment equal to the moment of the force about the point to which it is translated, which is called the theorem of translation of a force. In actually, we can use Chinese. That means lead means the force. Lead translation means 平移. principal theorem we call 平移原理 or 平移定理, you know? So this is, that means if we want to translate translate this f from A to B, we only need two steps. Step one, we just at point B give this, I'm sorry. So the step one, where my pointer, I can find it. Okay. Step one, we should give difficult. Give this f, which have the same direction and magnitude with this. Second, we should give a what? Give a couple. This couple actually equal its value should equal this original force, its moment to this point. Right? Actually, this couple should equal MBF. Actually, it's equal F times D. This D is the point we want to move on to, a distance from the original point A, right? And this direction we should know. If it is counterclockwise, it will be plus or positive. And if it in the clockwise direction will be negative minus. So it may be plus, it may be minus. So that the 力的平移原理, the theorem of translation of a force. Actually, the middle one is try to prove that. I think I have introduced to you guys last time. Actually, we add a balanced sub-force system here. It will not affect the final result to this body. And then we can find actually when we give this sub-balanced force system, this F prime have the same direction of F and same magnitude of F. And this F2 double prime also have the same magnitude with F prime and opposite direction of F prime. So this two force is the sub-balanced force system. So because we have that principle, we can add or subtract a sub-balanced force system onto a body and the body system without change its original state, right? Then you guys can find actually this F double prime and this F can constitute a what? A couple, right? A couple. So it can be denoted like this. So because we can use this M, which magnitude is F times D, have the same effect of these two force. Because these two force, F double prime and F, is a couple, right? So it's more like that we move translation of this F from A to B, and we add another couple. This couple is magnitude equal what? F times D. So this is a very important principle. When we have this, we can translate all the force to a given point. Then we can change the general force system into a special force system, which will let our simplification task from complex change into simple, right? That way we talk about changing the line of action of a force, right? So let's continue. So let us do some analysis. The first is the theorem of translation of a force gives a relationship between the force, maybe the original force F, and the force couple. So that means at point A, do you guys remember? At point A, we have F. Actually, it effect plus a couple at point B, right? Point A and point B. So that means it it kind of gives a relationship between the force and the force couple. Force is effect equal another force plus a couple, right? The difference is its action point is different, right? So when you do the translational move of a force, you always should remember you should add a moment to the new point, right? So that's the first analysis. Second, the condition of translation number force is to add a couple m, which is called the couple of transfer. So I think maybe in China we can call that 平移力矩 or 平移力偶. So it's more like why should we give or why should we add this couple of transfer? We just try to keep this F plus M have the same effect to the body with this original force, right? So where M is given by F times D, actually it's equal MAF. So once again, you guys should pay more attention to its direction. So if it CCW counterclockwise, it will be plus. It will clockwise, it will be minus, right? And third, the theorem of the translation of force is the theoretical basis, 是我们的理论基础. Theoretical basis means 理论基础. It is our theoretical basis, 理论基础. For what? Theoretical basis for what? Of the reduction of a force system. So it tells us, or it has a hint. We will do some reduction of a force system, right? It's our final task. Before that, we should know this translational theorem or theorem of translation, right? I hope you guys can totally understand this principle because it is very important. Maybe you'll use this theorem many times. So we will repeat that. Then you guys will uh, totally grasp its knowledge point. Right? When I say knowledge point, actually I mean in Chinese 知识点 knowledge point. I don't know if that's correct in English. Knowledge point. That means something you should learn. Maybe it's a kind of skill, right? It's a kind of skill your guess should be grasped, right? Okay, let's move on. So actually, it's just a two picture, and here you guys may be confusing of this Chinese sentence. It tells maybe I can read it for you. 钳工, 钳工 means a kind of worker. So in English, it means bench work. So we Chinese call that 钳工. This man will always stay by a station, made using some tool. Actually, this 司机 means tap. Do you guys know? Actually, tap means this is some kind of tool. When we use this tool, we can this yellow part have some hole. Hole in Chinese means 孔. We want to manufacture or to have some internal thread or internal screw. Screw means 螺纹, So we have both, This kind of things we use that very often, very often. You can think about the last time I had that because you can see my water bottle again. Can you guys see? I'm sorry. So actually, it's kind of screw. I can try to give a couple let this lead rotation have a rotate around some angle. Maybe I can open the bottle. Maybe I can close the bottle, right? So actually, it tells us when we try to make some internal thread or internal screw, we can use this tab called 3 or tab with this addition. So actually, we give this. We can use this, but more in very often we should give FA at A here and FB here. So FA and FB have same magnitude, opposite direction. Actually, these two forces will constitute a couple, right? A couple actually is Leo. Right? So this is an example. Let's continue. So we will move to second part, the second section of this chapter. We will talk about reduction of a force system to a given point. So we should think about that. Why we should reduction of force system? Because we try to talk about its equilibrium condition of a general force system. What is a general force system? It's more like this, you know. So we have three axes to denote three directions, and we have a body here with yellow color. Maybe there are a lot of force acting at different points on this body. So if we try to talk about its state, maybe in equilibrium condition, maybe not. But how we can get that conclusion? So the first uh, thing we should try to change this general force system into a special force system or into a simple force system, right? So the first is let us consider a force system in space. Space in Chinese we call that 空间, right? 空间 means 3D, three dimensions, right? Because we have X, Y, and Z. And on the raised body. So we have F1, F3, maybe N number of force in space. If we talk about a force in space, then actually maybe it will have three opponents. We have F1, X, I. We have F1, Y, G, and we have F1, Z, K. Means actually this is the force vector. It will have three components along three axis direction, right? So actually this one can be any value, can have maybe positive or negative sign. Then it will denote any direction of force and denote any value of force in space, right? So reduce the force system to an arbitrary point O. So actually we will select this arbitrary point O and let this O at the original point of this coordinate system. Then we will try to do what? Reduction this. So how will we do that? So we will just use the theorem of translation. We will translate all the force using the translation theorem. So you can see if we translational move this F1 from this point to point O, so we will have F1 prime. It has the same magnitude and direction of the original F1. But we also should give M1, which is M1 equals what? MOF1, right? Actually, it equal what? If we link O and point maybe at, let's say this point is B. So we will link O and B. We will get it position vector. Actually, this M1, you know, it will be R vector cross product F1 Actually, this content we have learned from the very beginning of the first chapter and the first class, maybe. So do you guys remember that? If you not, if you have very little impression, you come back to our PPT slide, chapter 1, right? It is IGK and X, Y, Z. That means the three components of a position vector R. And F1X, F1Y, and F1Z, right? We just need to determine or calculate it determination of this one, right? Actually, this is M1. It's another vector. We can just use right-hand rule to find its direction. So maybe here is a little bit difficult to understand, but don't worry. I only need you guys have a kind of impression is enough, right? I think it is time for us to have a short break. And we will restart at 11:10, right? You guys have a
Yeah.
rest.